Hi guys, and welcome back to the Math Society. So for this week, we'll be doing chapter 1, past paper. So for past paper, we'll be using this book. I actually printed this book, or like, should I say I wrote this book? It's not like I write the question by myself, but I collected questions chapter by chapter and I make this book. So this is actually mine. So we'll be using this book. And so let's get into it. Chapter 1, past paper. So let's go to chapter 1, past paper. So I collected all the questions from 2020, and I've been meaning to make a new book for 2021, but I have too much work. So it's not an excuse. I actually have a lot of work to do, so that's why it's delayed. Currently, I'm doing it's not like a past paper book, but it's more like a workbook for extended mathematics, which will be coming out, I hope, by the end of this year. I've been doing that, and that's why I've been busy. See, it's not an excuse. So after that, I still have 3 more books that I want to establish, and then that I want to print, and then I will get back to Additional Mathematics 2021 book. So bear with me until then. Okay, so this is from 2020. It's from February, March, May, June, and October, November. So for function, I currently have 5 questions here. So let's get into it. So the first question is they're asking us to draw a modulus graph. So I believe you've already know everything that you need to know from chapter 1. So I'm just gonna show you how I normally solve, and then I'm not gonna go into like step by step in details. So I'll just show you how I would solve these questions. Okay. So firstly, I'm just going to find my point. So I'm going to take out the modulus and find my point. So I'm going to let x is equal to 0, so y is equal to -7. And I'm going to let y is equal to 0, so my x will be equal to 7/5. So 0, -7, which is supposed to be down here, but since I'm drawing a modulus graph, I'm going to put it up here, plus 7. And then there is going to be 7/5. And then I'm just going to connect those, just going to connect those two. Okay, and that's it. This is my y is equal to modulus of 5x minus 7 graph. And that's it. So let's go to question number 2, B. So for question number B, I'm gonna move everything to the other side except modulus here. So it's going to be 15. So 5x will be equal to 10, so x will be equal to 2. And in here, 5x will be equal to 4, and x will be equal to 4/5. And that's it. Pretty easy, right? So let's go to another question. So they want us to find an expression for G inverse. So y is equal to 3 plus 1 by x. X is equal to 3 plus 1 by y. Keep in your mind that for every whole number there, if you want to make them into a fraction, you can just put 1 underneath. So for every whole number, like 3 can be written as 3/1. So I'm just doing that because I want to flip my fraction. I don't want to like multiply crossly. I'm just going to flip it. So this will become 1 by x minus 3 and y. If I got y, I got G inverse. 1 by x minus 3. And I'm going to read the question again to make sure they only ask for G inverse. Sometimes they will ask you the domain, and sometimes they will ask you range. So don't miss those points, so you have to read the question again. In here they only ask for G inverse, so I'm done. Okay, and I got an eye infection, and that's why my eye is red. I did not cry before this video, it just I have an infection. So now for question number B, they ask us for the range of G inverse. So for range of G inverse is the same with domain of G of X. So I'm just going to have to write down this thing, which is y greater than or equal to 1. Okay, so number C, find the domain of G inverse of X. So in here, it's like to find the domain of G inverse, I'm going to have to find the range of G of X. This is a little bit tricky for this question because normally we would just substitute 1 and then we would say it's 4 and we will call it a day. But in this question, it does not work like that because whenever you're trying to find range, you always have to look at the graph of the thing that you're trying to find. In here I have 1 by x, so I'm gonna have to think a little bit more. So I'm going to substitute 1 first. So G of 1 will be equal to 3 plus 1, so which is equal to 4. So I already know that my one part of my y is going to be greater than or equal to 4. Right? Now I'm going to have to think because my graph is 1 by x. So 1 by x graph, if we draw it like this. This is our 1 by x graph. But since we have 3 plus 1 by x graph, if we have to draw, our asymptote is going to be at 3. So it's going to be like this. Okay? So that means that the lowest value that I can take is very close to 3, but it's not 3. If you don't get it, like if you don't get the graph that I'm drawing, then you could have tried and substitute more number inside. So let's say that I'm going to find out G of, after I find out G of 1, let's say I'm going to find out G of 2. So G of 2 will be 3 plus 1 by 2, so which is going to be 3.5. How about G of 3? So G of 3 will give you 3 plus 1 by 3, so which is going to be equal to 3.33 something. So it's getting pretty close to 3, but it will never touch 3 because, see, let's say that we have G of 100, so it will be 3 plus 1 by 100, so which will give us 3.01. So it will keep going to like very close to 3, but it will never touch 3. So that's why our domain of G of X, so X value, it's going to be between, so it will never touch 3, but it will touch 4. So it's going to be between 3 and 4, and that's it. See? So that's how you would find domain of G inverse, which is range of G of X. So finding range, sometimes it's a little bit tricky because like you will always have to look at the graph. So let's find the range of f here for number 3. So for number 3, to find the range of f, I just have to substitute x is equal to 0 because this is just a normal parabola graph. So f of 0 will give me 0 plus 3 squared, so it's just 9. So my range y is just greater than 9. Keep in your mind that if your domain is x greater than or equal to, in your range you will have to write equal to. But since there is no equal to here, I don't have to write it. I don't need it, okay? So now I have to explain why function f has an inverse. So normally when they ask me to explain why my function has an inverse, I would just write that my function is a one-to-one function. So that's what I'm gonna do here, because f of x is a one-to-one function. Only one-to-one function can have inverse. So now I'm gonna have to find f inverse. So f of x, so y is equal to 2x plus 3 the whole square. I'm gonna have to exchange my x and y places. So x is equal to 2y plus 3 the whole square. I'm gonna move around, rearrange the formula for y. So this will give me square root of x is equal to 2y plus 3, and I'm gonna move my plus 3. So square root of x minus 3 is equal to 2y, and this will give me square root of x minus 3 divided by 2 is equal to y. So then f inverse of x will be equal to square root of x minus 3 divided by 2. And I'm gonna check the question again. They just asked for f inverse, so I'm done. Now for number D, they want us to state the domain of f inverse. So domain of f inverse is the range of f of x. So then it's going to be x greater than 9, and that's it. So for number E, okay, so number E is ln. Ln is log. Log is from chapter 6. So I think we should come back to this question later on, since it's log, and I haven't explained log here yet, so I'm gonna skip 3E and then we'll go to question number 4. Oh, the last question. I'm gonna have to find g of h of x, which is equal to 7. So normally, if I have already found g inverse, I would have just done this. I would have just moved my g function to the other side, and I will just say h of x is equal to g inverse of 7, and I will solve that, which is something that I can do here because g of x isn't that hard to find g inverse. But I'm going to find g of h of x function just for you guys, okay? So g of h of x will be equal to g function here, and then h of x is just square root of 2x minus 3, and I'm gonna substitute it in my g function. So that will give me square root of 2x minus 3 plus 5. So then square root of 2x minus 3 plus 5 have to be equal to 7, and I'm gonna move around. So square root of 2x minus 3 is equal to 2. So 2x minus 3 is equal to 4. So 2x is equal to 7, and x is equal to 7 divided by 2. And this is it. This is x. Okay. I'm just double checking my answer, because like sometimes when you move square to the other side, it will become square root, and then you will have to have two answers, plus and minus. Do not forget that. But in here, I did not move square, I moved square root, so that means I will only have one answer. So I think my answer is correct, hopefully, because I don't want to retake this video again. Okay, so let's go to the last question, question number 5. So I'm just, there's two ways to solve this one. We can actually use the method from chapter 5, but since we are in chapter 1, I'll just use chapter 1 method, which is like plus, we'll solve the positive side first, and then we'll solve the negative one. So 3x minus 2 is equal to 4 plus x, or 3x minus 2 is equal to minus 4 minus x. So let's solve this one. So 2x is equal to 6, so x is equal to 3. So for this side, it's going to be 4x is equal to negative 2, so x is equal to minus 1 by 2. And that's it. So let's try checking. I normally do not do checking because I'm lazy. So when x is equal to 3, let's see our left hand side. So left hand side will become modulus of 9 minus 2, so which is 7. And for right hand side, it's just going to be 4 plus 3, which is 7. So that means this is our solution. So let's try for x is equal to minus 1 by 2. So for left hand side, it's going to be modulus of minus 3 by 2 minus 2, so which will give me minus 3 minus 4 divided by 2. so which will give me minus 7 by 2, so which is 7 by 2. Okay, and for right hand side, it's going to be 4 minus 1 by 2, which is 7 by 2. So that means both of my solutions are fine, and so I don't have to reject any solution. So, oh, this is it. This is the end of chapter 1. Okay, so we have finished reviewing chapter 1. So we have also finished doing chapter 1 past paper for 2020. And I guess for next week we'll go to chapter 2. And in chapter 2, I believe there is simultaneous, and then there is a parabola graph, and there is more modulus, and then there is something you have to solve with discriminant, which is b squared minus 4ac. And I believe that's it for chapter 2, hopefully. And so I'll come back again with new video next week. Bye bye.